Today we're going to be doing the segment addition postulate. Please make sure that you are either in first, third, or fifth hour advanced geometry. If you're not, you're watching the wrong video. So what we're going to do first is to look at how the segment addition postulate is broken down. So what I want you to do is to pause the video and draw this diagram in your notes. When you're done drawing, you can play it again and we will write down some of the pieces. So go ahead and pause the video right now. Okay, now what we're going to do is we're going to highlight some of these areas. So for example, let's get a red pen. That's definitely not a red pen. Here's a red pen. Yellow doesn't show up down here very well. So red, and I'm going to say that's segment AB. I'm going to go ahead and get my green and say green represents segment BC. And lastly, I'm going to use my blue one for AC. That's the entire piece. So basically all that the segment addition postulate is going to state is that AB plus BC equals AC. In other words, this portion plus this portion equals the entire segment. Pretty basic, but you'll see how we can apply this later algebraically. So now we are going to try an example by finding the length of JL. Now before I look at any of these numbers, I want to go ahead and write down what the segment addition postulate states, and I think that's a good habit to get into. So this one is segment JK plus segment KL is equal to segment JL. Now I can put some numbers in here. So for example, segment JK, which I did in red there, has a length of 19. Segment KL, okay, which I did in green, has a length of 48. And obviously the segment addition postulate has set it up for us already, and we're just going to add 19 plus 48 is 67. So segment JL has a length of 67 units. Now we can go ahead and try another example, and again very similar. We want to do the length of segment QR. Now before we do this, again we'll start by writing down segment PQ plus segment QR equals segment PR. Now we can plug in a few values. I didn't put any of these in colors, but we can kind of see exactly what's going to go in. So PQ has a length of 35. QR, obviously that's what we're trying to find. PR has a length of 60. So from here, now we just solve this algebraically. So we're going to subtract 35 to both sides. And QR has a length of 25. So to practice segment addition postulate, we can do this without some numbers. So notice first we're told to draw a sketch of 3, there's our word we did last week, collinear points. Then we want to write the segment addition postulate for each of the points. And I'll do the first one. You can go ahead and do the next one in your notes and double check to make sure you're doing it okay. So I'm going to go ahead and draw my line. Again, 3 collinear points all in the same line. Now we want to make sure that A is between T and Q. So I'm going to put A here, have T and Q. So again, we're writing that TA plus AQ is equal to TQ. That is the segment addition postulate. So when I tell you write the segment addition postulate, that's what I mean. So what I want you to do is to pause the video, and then you can check to see if you did B correct. Okay, let's see if you did B correct. So again, we want to draw our 3 points. M doesn't have to be right in the middle, but it has to be at least between them. So H and A. And again, we're going to write for the segment addition HM plus MA equals HA. Okay, so we have two more examples that we'll go through. The first one, again, is using that segment addition postulate, but now we're throwing some variables in there. So I'm going to start it out the same way. That segment AB plus segment BC is equal to segment AC. So let's go ahead and write in the length of AB. So length of segment AB is x plus 8. BC has a length of x plus 10. And then finally AC, I wrote it in already, but it has a length of 20. So now notice from here down is just straight algebra. So we're going to, again, combine our like terms. We got a positive x, so positive 2x, positive 8, positive 10, plus 18 equals 20. Subtract 18 to both sides. 2x equals 2, and after we divide by 2, x has a value of 1. Now this next example, it's kind of a culmination of everything that we've done so far. So if you want to try this example out on your own by pausing the video and then checking to see what your final answer is, that's fine. I think it's probably good practice. Otherwise, you can take notes on this problem that I've done, and we can discuss it more tomorrow. So again, we have, suppose J is between H and K. Again, we're going to use that segment addition postulate to solve not only for x, but I want to find the length of HJ, JK, and KH. Well, we already know that one's 22. So that's our final thing we want to do here. So let me just draw a quick picture of what this is going to look like. Again, we're going to put J in between H and K. Now we know HJ 2x plus 4. Let's see if I can write this small. Looks like it. JK is 3x plus 3. And that entire length, again, is going to be 22. So let's determine what that means. So again, let's write in our segment addition postulate. So HJ plus JK equals HK. Now we know a couple of these things. HJ, again, similar to the last one, has a value of 2x plus 4. JK has a value of 3x plus 3. HK again, same as KH. Notice different order, but same thing. So that's equal to 22. Combine our like terms, 3x and 2x, so 5x plus 7. Subtract 7 on both sides. 5x equals 15. And we're going to have x as a value of 3. Now again, that's part of what we want to do, but we also want to find the actual length of HJ and JK as well. So again, originally we said that HJ has a value of 2x plus 4. So we're going to, again, substitute in what we just got. Our value of x which was 3. So 2 times 3 is 6 plus 4. HJ has a length of 10. Okay. Now JK, same thing. We can just go ahead and plug that in. 3x plus 3. So 3 times 3 plus 3, so 9 plus 3 in other words, is 12. And again, we can check 10 plus 12, so 10 plus 12, piece plus piece, makes the entire thing, which is 22. And it makes sense. So I want you to go in and fill out your WISC form for tonight. Be sure to include a question on there that you still have, or a question where if you don't have one, maybe someone else might have had one where they got stuck. And we will discuss this a little bit more tomorrow in addition to midpoint formula and distance formula. Have a good night.